In this section, what we're going to do is we're going to begin to look at a system of linear equations. And so before we ever get into this idea of system, because we already know our thoughts on linear equations, we're just putting multiple lines together. I want to start with some vocabulary. If I start putting multiple lines on a graph, what's going to happen is I'm either going to create one of three situations. Either an independent situation where when two of those lines cross, they cross at one point. And we say that this type of system has exactly one solution. Graphically, we can see that they're crossing at one point. They are intersecting at one point. And so this is known as an independent system. If we talk about two lines, you can see in the next example, those are parallel. Well, what's happened is since we have parallel lines, it's going to result in no solution to that system, because it's known as an inconsistent system. We group some lines together. Yes, graphically they were parallel, but in terms of what do they have in common, we don't have one solution in common. We have no solution to the whole system. It would be known as an inconsistent system. Now, you can't see it as well on top of this one, but what's happening is I have that blue line. That's my first equation. And then what I would do is I graph the next one, and it just graphs perfectly. Make that a little bit more perfectly. It graphs perfectly on top. Well, you get the gist of that. It graphs perfectly on top of the other line. And when does this happen? This happens when you have lines that are coinciding. And so it doesn't give you one part of intersection or one solution. It's not no solution where they're never crossing. This gives you infinitely many solutions because they're crossing at all these different ways. And so what I want to do is I want to begin looking at these systems of equations. We can see the answers we're going to get: infinite, no solution, one solution. Let's first start with how do we tell if something is a solution? Then we'll look into the solving of it. So it says determining whether an ordered pair is a solution to a system of equations. Determine whether the ordered pair 8, 5 is a solution to the given system of equations. So I'm going to look at the two equations. So I've grouped these two equations together. This is my system. And I want to figure out, is 8, 5 a solution? So is it an independent system? The way that we're going to be working this is we're going to check it into both of our equations. So first equation is 5x minus 4y equal to 20. So this is my x value, my y value. I'm just going to plug those in for x and y, but I'm going to leave everything else where they were. And what I'm checking for is if I have a true statement. So I'll work my arithmetic. This gives me 40 minus 20, bringing down the 20. And then this combination together, 40 minus 20, gives me 20 equal to 20. And this gave me a true statement. 20 does equal 20, so that means that this ordered pair or this point is on that equation. Now I'm trying to see if this point, 8, 5, will be correct for both equations. Because if it's correct for both equations, that means I have this independent system. It's crossing at that point because it's going to be true for both of them. And so I'll say step number 2, I'm going to take 2x plus 1 equal to 3y, and I'm going to plug in my x to be 8, my y to be 5. So 2 times 8 plus 5 equal to, Just making sure you're on your toes there. There's my 5 plus 1 equal to 3. So I plugged in my x to be 8, my y to be 5. And then I'm just going to check if the left side of the equal sign equals the right side of the equal sign. So it gives me 16 plus 1 equal to 15. So 17 is equal to 15, which is not true. So that means since I got a true and a false statement, 8, 5 is not a solution to this equation. I would have to get two true statements for that to work out. And so this is just a simple exercise of figuring out if an ordered pair works for a system. Now, this is going to be a really good checking for us once we get an answer to make sure it all works out. But let's go into the algebra sense of, okay, well, we have two equations. We've grouped them. We're calling them a system. We know what our answers are going to look like by our graphs and definitions. But how do I get to the point of what is the solution to that entire system? And we're going to take it a couple of different ways. The first way is we're going to solve a system of equations by substitution. Here's our steps for solving by substitution. 1, we're going to solve one of the equations for one of the variables. When you're looking for one of those variables, be easy on yourself. Look through all the x's and y's and say, okay, what's the easiest one to get by itself? Number 2, you're going to substitute into the other equation and solve. And I'm not saying first equation and second equation because it's going to depend on what they look like. 3, plug back into either equation and solve for the other variable. 4, check your answer. So that all, does that even make sense? But I wanted to give you those steps to start with. And then what I'm going to do is I work through these. I have 2 examples to go with this one. I'm going to show you those steps in the process. Okay, so solve the following system equations by substitution. Here's my 2 equations. I am trying to find some ordered pair of x, y that work for both of those situations. So here's what I'm going to do. Step 1, I'm going to solve one of the equations for one of the variables. Now, if you look at those 2 equations, you can see x is already been solved for. So that means, that's why I didn't say look at the first one or the second one or look at x, look at y. Pick what is easiest. X is already by itself, so step 1, done. I've got x equal to y plus 3. Step number 2 says to substitute into the other equation and solve. So since equation 1 had the x by itself, that means I'm going to plug that into equation 2 for my x. So I have 4 equal to 3 parentheses. So instead of x, I'm now going to call it y plus 3 minus 2y. Then step number 3 says to plug back in. So step 2 was substitute into the other equation and solve. Excuse me, I need to finish solving. So I'm going to distribute. That gives me 4 equal to 3y plus 9 minus 2y. Combine your y's. So I get 4 equal to 3 minus 2 gives me 1y plus 9, and then I could subtract that 9. Let me move that over so you can see it a little bit better. Here we go. So that was that 1y, so I'll subtract the 9. That cancels it. I get negative 5 equal to y. I just moved this up here. So now I have a y value. And I could even just go ahead and plug that in that ordered pair I'm hoping to get. Step number 3 says plug back into either equation and solve for that variable. Now it doesn't matter if I subbed into equation 1 or 2. I'm going to go back into equation 1 because it already has an x by itself. So my arithmetic will be okay. So x is equal to, I'm going to plug negative 5 into that y plus 3. So that gives me x equal to negative 2. Now I have that x value. So negative 2. Now step 4 says check your answer. We did a whole lot of algebra with that. So let's just check and make sure we've got it. So I'm going to take the x equal to y plus 3 and I'm plugging in this ordered pair I've gotten. So I'm going to say negative 2 equals negative 5 plus 3. That gives me negative 2 equal to negative 2. That's true. I feel good about that. I'm going to plug it into the second equation, which was 4 equal to 3x minus 2y. So that would be 4 equal to 3 times negative 2 minus 2 times negative 5. I'm just using this ordered pair. 4 equals negative 6 plus 10. So 4 is equal to 4. This is a true statement. So that means since I got 2 true statements we saw from the previous example, that's a solution. So I feel confident in my steps of substitution here. I'm going to work another example with you because not all equations are going to be set up to be the same. So I'm going to look at this next one. It says solve the following equations by substitution. So I'm going to work through my 4 steps and you've got your 4 steps written on your notes. It says solve one of the equations for one of the variables. Now when you look throughout these, you're going to say, okay, here's an x, y, y. What is the best one that I want to solve for? Well, it doesn't matter which one you solve for, but I'm looking at it. I'm thinking this y is going to be pretty easy. It doesn't have a 2 or 5 attached. It doesn't even have a negative attached. So for me, step 1, I want to take the easiest route here. I am going to get this y by itself. To do that, I'm going to have to add x to both sides. So it gives me y equal to x minus 5. So I can see that I now have step number 1, solve one of the equations for one of the variables. I was able to get y by itself. Step number 2, I'm going to substitute into the other equation and solve. So I'm going to take my second equation, 2x minus 5y equal to 1, and I'm going to sub in what y is equal to right here. 2x minus 5, y is now x minus 5 equal to 1. And it says to solve. So I'm going to distribute. Be careful when you distribute. You are distributing a negative 5. So 2x minus 5x plus 25 equal to 1. I'm going to combine these x's together. That gives me negative 3x plus 25 equal to 1. And then isolate this variable. So minus 25. That gives me negative 3x equal to negative 24. And divide by negative 3. So x is equal to positive 8. I'm halfway to answering this. So I'm looking for an ordered pair. That means my x is going to be equal to 8. I'm on to step number 3. Plug back into either equation and solve for the variable. So it doesn't matter where I plug it back into. I'm just going to go back up to this top one, negative x plus y equal to negative 5. I now know an x value, so I'm saying negative 8 plus y equals negative 5, and I'm going to add that 8 over. Again, it doesn't matter which one I'm plugging into because it's going to work for both. That's my goal. And I'm able to get y to be 3. So I have my answer of an ordered pair from 8, 3, but step 4, I'm going to check my answer. So I'm going to check it in both equations. Say in negative x plus y equal to negative 5, does it work? Negative 8 plus 3 equals negative 5. That's negative 5 equal negative 5. Check. That worked out. Now, if I didn't get 2 true statements, I probably messed up my solution. I need to go back and check for clerical errors. I'm checking in my other situation. I get 2 times, I'll just write it, 2x minus 5y equal to 1. So that's 2 times 8 minus 5 times 3 equal to 1. So 16 minus 15, 1 minus 1 equal to 1, excuse me. So that works out as well. So I feel confident in my answer of 8, 3. Now, substitution is one way that can solve a system of equations. The other way that we're going to learn is known as elimination. And I really like this way. It comes in handy. It says, step 1, create opposites for one variable. Step 2, add the equations to cancel out one of the variables. 3, solve for the remaining variable. 4, plug back into either equation and solve for the other variable. And 5, check your answer, just like what we did on substitution. So again, just pause if you need to, jot down all these steps in your notes, and then hit play again. What I'm going to do is I'm going to take this example and I'm going to show you all the different steps I'm going to get to. Now, not all equations are the same, so I am going to work a couple examples and build up to this. So it says solve the given system by elimination. Now, if it tells you elimination, practice your steps. If it just says solve, go with elimination. Substitution you either feel more comfortable with or it's easiest to work through. So in this one, it says create opposites for one variable. What do we mean by that? We mean like positive 1, negative 1, positive 2, negative 2. So opposite sign. This is not opposite reciprocals like you may have done with perpendicular lines. So in this case of step 1, I already have opposites in the sense of my x's are a positive x and a negative x. So check, I'm good for step 1. I didn't have to do anything. Step 2 says to add the equations to cancel out one of the variables. And so what I'm going to do is I'm going to add these two together, vertically adding them. You can see that my x's are lined up, my y's are lined up, equal to my constant. If that's not the case, reorder. So I'm going to add the two equations together. X plus negative x cancels. That's my goal. This is an assumed 1. 2y plus 1y gives me 3y. equal to -1 plus 3 gives me a +2. Now I have y only, so I'm just going to divide both sides by 3, and I get y to be 2/3. Now our end game is still going to be our solution of x comma y, so I'm already halfway done. So it said add the equations to cancel out one of the variables. Check, I did step number 2. Step number 3 says solve for the remaining variable. And so that would be here when I got y by itself. Step number 4 says plug back into either equation and solve for the other variable. So I'm just going to plug back into my top equation, not for any reason, but that it was listed top. So I have x plus 2 times 2/3 equal to -1. That gives me x equal to, let's see, 2 times 2/3, not equal, I want my addition there. X plus 2 times 2/3 gives me 4/3 equal to -1. And then I can subtract 4/3 over. So x is equal to -1 minus 4/3 is -7/3. Now don't stress when you're working through these answers. Our goal is an ordered pair, and it is okay to get fractions. Step number 5, I want to check my answer. And so I'm going to take this and I'm going to plug it into both equations. So if I plug it in the top equation, that gives me -7/3. I'm just using this equation here. Plus 2 times 2/3 equal to -1. That gives me -7/3 plus 4/3 equal to -1. That is -3/3 equal to -1, which is just -1. So that worked out. Plug into your second equation. That gives me negative. Again, I'm plugging into the second one here. -7/3 plus 2/3. And it says that that is going to be equal to +3. Negative give me a positive. And adding those together gives me 9/3. 3 does equal 3. That's the reduction of the 9/3. So again, it worked out. Now you can see sometimes with elimination, it goes quickly based off what was given. If I had done substitution, I'd have to do an additional step because I wouldn't have a variable by itself. It's really just what you're going to be either comfortable with or what it's asking for. I want to work another example. I'm going to work quite a few of these, and we'll go into just solving in general. And again, I want to work through these steps. Step number 1 is to create opposites for a variable. So if you look at your x's, you can see that we have 3 and +1, different numbers, both positive. If we look at -5y and -2y, we do have a positive and a negative, but we don't have the same number. So in this example, we're going to have to create opposites on one of these variables, and it doesn't matter which one. In this case, I'm going to create the opposites on the x's. So in order to do that, I need this x right here to be a -3. It's in a 1 because it's assumed 1. So if I multiply everything in this second equation by -3, that gives me -3x. I'm just distributing plus 6y equal to -33. So I now have, I'm going to move that first equation over. Now have opposites on my x's. I have a +3 and a -3. So here, I'm going to go to step 2, and I'm going to add these two equations together. So my first equation and my new second equation. So 3 minus 3, that cancels. 5 and 6 give me 11y equal to, I'm just adding vertically, -11 and -33, which is -44. Divide both sides by 11, so y is equal to -4. Halfway to my answer. So that gives me my y value. So step number 3 is solve for the remaining variable. Step 4 says plug into either equation and solve for that variable. So step 4, I'm just going to plug -4 into that top equation. So 3x plus 5 times -4 equals -11. I'm going to solve for x. 3x minus 20, I just multiplied those two together, equals -11. I'm going to add 20. Gives me 3x equal to +9 and divide by 3. So x is 3. So now I have my ordered pair of 3, -4. Step 5, I can just check my answer. So I'm going back up to my original and making sure it works in both of those original equations. So that would be 3 times 3 plus 5 times negative 4 equal to negative 11. I get 9 minus 20 is negative 11. So it's negative 11 equals negative 11. I'm good on that one. 3 minus 2 times negative 4. 3 plus 8 gives me 11. And 11 does equal 11. So just kind of step 5 is just checking this solution that I've already gotten. So you can see elimination works really nice in some situations. I want to keep walking through this elimination process and do some different examples for you to make sure you know what to do with the answers that you've gotten. So I'm going to look at this example next. So first I'm going to create opposites. I'm going to create an opposites on my x's. So 4, I would need a negative 4, so I'm going to have to multiply everything by 2. Now, as long as I multiply everything, I'm not doing anything wrong. So this gives me 4x minus 2y equal to 12. That's my first equation. When I distribute that 2 in this bottom one, I get negative 4x plus 2y equal to negative 12. Step number 2, I'm going to add these two together. So this cancels. That cancels, and that gives me 0. Well, that gives me 0 equal to 0. That's weird. True statement. This is true. 0 does equal 0. This is the situation that we started with. This is where you have dependent or coinciding equations. And so what do we say the answer is? We do have an answer. It is infinite many solutions. So even if your x and y's all cancel out, finish out the problem. Because here, because it was a true statement, it was infinitely many solutions. So I wanted to do this one specifically. So when you encounter this, you don't go, oh, what do I do? You have a way to finish out the problem. I want to work this next example because this next example has a little bit more steps to it. You come in here and you go, step 1, I'm going to create opposites. Well, these are both positive. These are both negative. I mean, this is a positive and negative. So maybe you go, I might want to cancel out the y's. But in this case, I'm going to have to do double the work to get that cancellation. And so in this problem, we'll just stick with our x's because they're out front. If I want to cancel this out, it's not a matter of, oh, let me multiply the top by something or let me multiply the bottom by something. It's a matter I'm going to have to multiply both of them. So it does have an extra step. In order to cancel these x's, I would have to create a 10. So I would want to multiply the top by a negative 5 and the bottom by 2. Now you can cancel the x's or y's. It does not matter which one you cancel. I want it to work this one because I'm going to have to double multiply this. So distribute that negative 5 gives me negative 10x minus 15y equal to positive 80. Really amps things up. Distribute this 2. I have 10x minus 20y equal to 60. Really big numbers, but look, I now have opposites. And again, you could have done the same thing with y's. I do the x's only because they're out front. Now I can add those two together. So this cancels. That's my intention. That gives me negative 35y equal to 140. And then divide by negative 35. So y is equal to negative 4. But halfway to my answer, I need that whole ordered pair. Now I'm going to plug that into either equation. Now I'm going to go back to my originals. So I'm going to say 2x plus 3 times negative 4 equals negative 16. So 2x minus 12 equals negative 16. Add 12. That gives me 2x equal to negative 4 and divide by 2. Went a little bit quicker with this one. My intent was to show you how you can also multiply both equations. And that gives me an answer of negative 2. Again, I could go into step 5, check it both.